Good morning.
So your expertise are well known, but the company is relatively new. So perhaps you could tell us about where you are, when you were founded, and what you do at NPROXX.
Yeah, NPROXX is a brand new company. We are founded last year. And maybe guests who have been to the exhibition last year, they know our former company, EMS. So we took out all our hydrogen activities into NPROXX and we created this new company. We belong to a company which has 550 employees and has a lot of experience with carbon fiber designs. And one of our products are pressure vessels for hydrogen.
We'll obviously have a lot to say about carbon fiber, but before we get to that important topic, one has to make a decision strategically that there's a business model out there, that the hydrogen economy is going to grow, that hydrogen fuel cells will become more popular. Did you study and then make the decision at some point, oh yes, there is a business model, let's form a company to service nothing other than hydrogen? Was there a moment where it clicked?
Yes, of course. We looked about 6 years ago into the market. What can we do with our expertise? What kind of products can we provide to the market? And we saw the problem of emissions, the problem of climate change, the high political targets we have to get emission-free solutions. So we came very fast to hydrogen. And we have seen that pressure vessels that make storage units, is one thing we can do. And now the markets are developing, and that's where we are today.
Hydrogen, of course, has the beauty of when you consume it in a fuel cell, it produces nothing but water, but it has a lousy energy density. It's kind of corrosive. How do you deal with the issues of hydrogen as a energy carrier, either for mobile applications or stationary applications? It's all about storing the fuel. How do you deal with hydrogen, and what are the specific issues?
You're right, it is a lousy fuel. The problem is if it is a gas, then you need to, the energy density, the volumetric energy density is very low. That means you have to compress a lot. You have to go to very high pressures, yeah, to store enough energy. For example, for a car or for a truck, to bring them the distance the truck wants to run. Yeah? So you need high pressures, and when we talk about high pressures, then we are talking about pressure levels like 350 bar, 500 bar, 700 bar, or even 900 bar or 1000 bar. And yeah, and that is the problem. So you need to consider materials. And when you go to these high pressures as a gas, and when you want to store it, then you are very fast. You come to materials like carbon fiber, who have a very high strength, who are flexible, and who can withstand the loads they have they are underlying. No?
When everyone hears the word pressure, we think of either that Queen song or high blood pressure. Pressure is always a bad thing, generally. For me, it's interesting. You learn a lot about storage capacities here. When you deal with high blood pressure, high hydrogen pressure, you're filling up those tanks. The energy inside is consumed. The pressure drops. Do you have to deal with this expanding, contracting thing? Are there load cycles and issues about wear and tear for tanks that you have to address?
Yeah, of course. I mean, you have to fill up your car. Yeah? When you go with your diesel car to a fueling station, you fill it up, and the tank is empty, and then you fill it up, and then it is full. So there are some forces which work on the tank. Yeah? In the gas area, or let's say in the hydrogen case, we name this load cycle. No? The tank is empty, you fill it up with pressure, but now with 500 bar or 700 bar or 350 bar, And these are really forces which attack the material of the tank. So this you have to have a material which is flexible and which is very strong, yeah, and at the same time safe. Yeah.
Do the carbon fiber tanks actually expand and contract? Are they kind of like balloons?
They are, yeah, let's say very simple words, yes. Okay. They are balloons, and especially Type 4 pressure vessels, which we are producing. Inside is a plastic liner. No? It is like a plastic bottle, which is very highly dense, so it keeps the hydrogen inside, because hydrogen is very small. Yeah. And around there are there's a winding, carbon fiber winding, so there are, it's like a weaving, yeah, a certain pattern, which entirely close these inliner and makes it stable. Yeah.
Okay, and that is, of course, the next question, safety issues here. People, for some reason, have their doubts about hydrogen and safety here. How do you test these storage devices, the carbon fiber tanks, to make sure that they are safe?
Yeah. Before I answer this, I have to explain a little bit about the products we are making into this hydrogen industry. We have a range of pressure vessels for vehicles, for cars, and also for trucks. So trucks and buses have 350 bar. Vehicles have 700 bar. So if you want to see a 700 bar pressure vessel, you can join us at our booth. And on the other side, you need fueling storage, yeah, and the fueling station. So we have there other levels of pressure, yeah. And we supply for all these applications special pressure vessels. Now we have to look, if we look at safety, there are a couple of standards we have to fulfill. Now, before a pressure vessel goes into the market, comes into a car or into a bus, it has to run through 25 different tests. There are very spectacular tests. For example, a bonfire test. Now you have a tank and it is under 500 bar, and then you have gas flames underneath. Yeah? So it is fully loaded, and you have to burn it. So, and the pressure vessel has to remain stable about 3 minutes. Yeah? So that's enough time to leave the area where the fire is. That is what we have to do, and these tanks are really, really safe. And the big advantage is these are plastic materials, so there is no corrosion, yeah, and they are really flexible. No? We are expecting in the future a lot of consumers which are coming on the road, because we are also developing now pressure vessels for cars. We are developing pressure vessels for trains, like the new Siemens train will have our pressure vessel. And so they are all coming. That means consumption will go up. That means we will have more load cycles in the fueling station. We will have more load cycles in these consumers. And this requires, let's say, new technologies for storage, new materials.
I know I'm stressing this point too much, but the acceptance of the technology is really related also to the notion that it's safe. Driving here to Hanover, would you rather be in a car crash with a pile of hydrogen fuel cell cars, or with a typical combustion engine and those big tanks with gasoline? Any preferences?
I would not have any. I would like to prefer no accident. Okay. With any car. I think also normal cars or gas cars are also safe. I have no fear for these technologies. Otherwise, they have no allowance to run to drive on our streets. And I think that is not the point. The point is that we want clean fuel, no emissions, and green energy, green hydrogen. I think that is the key point. And for safety, I'm driving a diesel car. I still have one. I would like to have a hydrogen car, but it's not yet the time. It will come.
So we're on the way to these applications, though, and let's go through the whole scale of applications. There are surprisingly large things. there's the smallest of the small forklift trucks and everything in between. But let's start with the large ones. What customers do you have right now?
Yeah, what customers do we have on the automotive side or on the vehicle side? We are talking with OEMs, car manufacturer, who are now planning on hydrogen cars, fuel cell cars. We are talking to companies who are doing the conversion of existing fossil fuel motors into hydrogen is also possible. We are talking to shipyards, who are now thinking to change their old diesel engine into, let's say, into fuel cell drives, with electrical drives. I don't know if you know it. For example, in Cologne, where I'm coming from, 30% of the emissions in the city are coming from the ships on the River Rhine. And this is one, let's say, one point where the governments can change something very rapidly if they attack these sources of emissions. So these are the customers on the automotive side. If we look on the storage side and on the fueling stations, so we are talking to integrators, who are doing fueling stations. We are just supplying the storage unit. By the way, you can see in our booth also an entire pressure vessel, real pressure vessel for our storage applications. We are talking also to integrators who are doing trailers, trailer setups. So somebody has to bring the hydrogen from the, let's say, from the electrolyzer station to the fueling station. And it's not always possible to have a pipeline. I think in still a long period of time, we will have gas transports via the street, to remote areas, or let's say to areas where there's no pipeline connection, for example. So, and you can see, if you are all invited to come to our booth and to see it in real size.
I think everyone understands the correlation between high pressure tanks, 700 bars, and how far you can drive in your car. And of course, that's the famous thing about the fuel cell car. It still beats the battery in terms of distance and refueling time. What about when you're transporting hydrogen? And I agree with you, right now there is no hydrogen grid. So there will be trucks delivering hydrogen to remote locations so you can refuel there. Are there advantages in high pressure tanks in terms of the volumes you deliver? I mean, the truck driver costs something per hour, the truck itself costs something. Are there any actual cost savings if you go to higher pressures when you're delivering hydrogen?
Yeah. Today, when you look at the hydrogen transportation, what we have on the highway today, you see large trucks with steel tubes. It's a very cheap technology, but they are running at 200 bar. So the infrastructure today for filling these tubes is at 200 bar, sometimes 300 bar. That is what, let's say, industry can deliver today. If consumption goes up, and if you go and collect your hydrogen to remote places where wind farms are and where electrolyzers are, then you have you have to calculate if 200 bar is useful. You can with a 40-ton truck, you can transport about 400 kilo hydrogen. If you go to higher pressure now, if you go to 500 bar on a transport on a trailer, then you can transport 1,000 kilogram hydrogen, so 1 ton. And if you have now a lot of consumers on the other side, sometimes it makes sense to go to these high pressures. Not all the time. We have to calculate the business case, and we have to see if it fits. Sometimes it's better to use just 300 bar. So, but as higher the pressure is, as more I can transport, and as more consumers are on the street, then I'm pretty sure I have to go to this high pressure transport.
It's interesting for me because it's actually a concept for reducing traffic on the road. You use higher pressure, you have fewer trucks.
Yeah, we have
necessary
fewer
to-
trucks. It's all a question of costs. No, you need specialized drivers. It is dangerous good. So yeah, you have to consider this. Yeah.
On the way to Hanover from Berlin, I live in Berlin, you pass through train stations and you see smaller communities that are sort of outside of the major cities, and they still have these damn diesel trains driving through the neighborhood. They don't smell very good. They often go through valleys, and all of the pollution tends to descend on the population there. Have you any solution for the diesel-driven trains?
Yeah, we are working, as I said before, with Siemens to develop the new train, the new hydrogen train. We are doing the total system of storage. This will be 350 bar. They have enough space on the roof, so they can run at 350 bar. And this is indeed a very good solution. I also live outside of Cologne, where we have a diesel truck rail. And so it's always, every year they are discussing, should we electrifying it or not? But it is very expensive. So I think hydrogen is a real good solution, yeah, for this application. Yeah.
Added to which, I love the fact they're quiet.
Yeah, it is like a battery train or like a battery car. I would recommend if you have never driven with a car like this, with a Toyota Mirai, for example, do it. It is really relaxing, and the noise level is very low. So when you live in a city, and I'm pretty sure in 10 years' time we will have a lot of battery cars and a lot of hydrogen cars in the city and no noise. Yeah, we are working, for example, today on a fueling station for buses. No, Cologne will get 20 buses very soon. This is Regionalverkehr Köln. And we are supplying storage for one of their fueling stations. No? And so 20 buses, very quiet buses with long ranges. This is, I think, the future.
And I suppose that's my next question. The future, where is the growth potential going to arrive first? What's going to happen in the changes towards, ideally, a hydrogen economy based on entirely renewable energy? What do you see happening first?
Yeah, I think due to this emission discussion and due to the emissions we have in the cities are, they have to look at the public traffic. So buses, trains, maybe ships, they will come first. If personal vehicles are coming also, I have my doubts because, let's say, smaller cars, because the fuel cell and storage is for hydrogen is not cheap, and I think their battery is a better option today. Let's wait and see what happens in the future. If the prices with maybe scaling up productions in fuel cells and in storage, maybe if the prices come down, maybe one day we will also find smaller vehicles. No? So that is the future I see, and I think I'm pretty sure in 10 years' time our cities here in Germany or in Europe will look completely different.
Do you feel there may be a supply side change? That is, we all know that renewable energies in the huge quantities that are available cannot be stored by the electrical grid. You need hydrogen as a massive storage device, and there are caves, salt mines, and things like that that you could fill. If there is this large hydrogen grid, is that a competing force for your business model, or will there always be a necessity for storage at high pressure?
There will always be a pipeline, and if a pipeline is there, it is certainly better to use a pipeline as storage or large caverns to use them for hydrogen storage. This is always, I think, this is the optimum. But to build these things, well, you have to have it. You have to have the hole in the ground, or you have to dig holes for the pipeline. I think it's not so easy, and it is very cost intensive. So I think the next 20, 30 years, or maybe for all of the future, transport via gas pressure vessels will always remain one option, but it was one option in the total picture. You know? And the other thing is, the production of power is sometimes in very remote areas. Yeah, like in Germany, it's in the north. We need the power in the south. So how do we transport it? And transport it via pressure vessels is one good option. No?
We're all trying to guess the future. Of course, as a new company here, we'd be interested in seeing what happens in your first years. Are you going to come back in 2020 and tell us how things have gone?
Of course we will do, and I'm pretty sure that it will be an exciting year, the next year, and yeah, you're all invited to join us and to discuss more, and we will. I'm pretty sure that we will come back. Yeah.
And until such time, of course, we can keep in touch with you via...
It's 52-1.
Oh, the booth is, I was thinking of the social media that you've got going.
Yeah, we have also social media on Twitter. We are on Twitter and we are on LinkedIn. So join us, look for NPROXX, and there we keep you updated with press releases on a regular basis. And where you can find it, which exhibition conferences we are.
And the advantage of your name for a new company, of course, is it's really easy to Google because it's one of a kind. I've been talking to Michael Ismar, who's manager of marketing and sales at NPROXX. The booth is D52. I encourage everyone to go back there and look at the storage tanks. It's very interesting to see the large stationary storage tanks that are available, and then the small mobile applications, safe. They haven't shown us the most interesting images, tossing a tank into a bonfire and roasting it like a sausage to see what happens. So the exciting stuff is still back there, shooting guns at the tanks and seeing what happens. Nothing happens, folks. They're safe. It's been a pleasure talking to you, Michael, and I hope to see you back here next year.
Yeah, thank you very much.
Thank you.